All right, let's talk about titration. Titration is actually a process that's used in lots of avenues of chemistry, but in particular we use it a lot in acid-base chemistry. So we'll talk about it in those terms. So what a titration is, it's a way of determining the molarity or the concentration of some unknown acid or base. And typically when you're doing titrations with acids and bases, you know the kind of acid and you know the kind of base that are there, but it's possible that you wouldn't know the concentration of one or the other, okay? So we know the chemicals we're working with, but sometimes we don't know the concentration that those chemicals are in. All right, so here is the thing about titrations. Titrations are actually really cool, I think. They require the use of something called an indicator. And an indicator is basically a chemical that when added to an acid or a base will change the color of the solution. And their indicators come in lots of different varieties. We have a couple that we use really frequently and one that we use like really frequently, and it's known as a base indicator. And so here's the way an indicator works. Let's say that we have a solution of sodium hydroxide, which is a base, okay? If we have this little dropper of chemical that we call phenolphthalein, and I'll talk more about that in a second, it's a colorless liquid that is added to this colorless liquid. We're talking about clear, transparent solutions of both. And when you just drop a couple drops of this indicator into a basic solution, it turns this solution pink, which is really cool, actually. And I'll show you a video of that as well. So an indicator is used to determine whether something is acidic or basic. And so if you didn't know what this stuff was and you put this indicator in and it turned pink, you could determine that it was, you wouldn't know much about it, but you would know that it is basic. Anyway, so here's phenolphthalein. It's a terrible word to say and even a more terrible word to spell. Phenolphthalein. We abbreviate it PHEN typically, and it turns pink in a basic solution, but if you added it to acid, you would not see any color change. It only indicates basic solutions, okay? Another one that's pretty common that we would use is called bromothymol blue, abbreviated BTB. And it actually starts out as sort of a greenish solution, and when you add it to an acidic solution, it will turn yellow. So those are two things that we would use in class, okay? So let's talk about how a titration actually works. So here's the basic setup for a titration setup, and I'll show you the parts here first. We have this long glass tube here, known as a burette, and it's a kind of a long open-ended at both ends kind of tube. It's got this little thumb screw down here, a little valve at the bottom that you can open and close, which allows any liquids that are in this burette to drop out the bottom. And then you have down here what's called the titration chamber, and so let's just talk about how this kind of thing works. So in the burette, you put what's called your standard solution, and you know what the molarity of that solution is, and for us, typically that's going to be a base that goes in here. It's going to be some hydroxide solution that goes in here. Doesn't always have to be, but it's a little easier way to get into titration. So pretend that your base is going to go in here, okay? We call that the titrant, and the burette allows you to open up the valve down here and allow a certain amount of this base to drop into the titration chamber, which is holding a known volume but an unknown concentration of acid. And so down here we have acid that we know what type of acid it is. We know how much of it we're starting with, but we just don't know the concentration, okay? But the titrant up here, the base that we're going to use, the standard solution, we know the molarity of that, okay? And so let's just pretend that we were going to add, let's just label this so we know what's what here. So let's just say that this is a base. Okay, and down here, this is an acid. Okay, and so we know quite a bit about the base. Let's just pretend that this is, we've made this standard solution and we want it to be 1 molar sodium hydroxide. Okay, so this is 1 molar sodium hydroxide that's in here. Now down here, this acid, we would have to know what type of acid this is. Let's say that this is hydrochloric acid, and let's just say that we're starting with 100 milliliters of that acid. Okay, so if you were to just add the base into the acid, you wouldn't really see anything happening, because if you think back to the reaction that's going to take place, all we're going to make is salty water, right? But what we want to remember is that the ions are recombining to make salt and water, and that's the neutralization part of this. And so the acid is going to receive a few drops of indicator, and we're going to use phenolphthalein in here. Okay, so when you put the phenolphthalein in here with the acid, you don't see anything happen, because phenolphthalein is a base indicator. If we were to put the phenolphthalein into the burette, the whole thing would turn pink, and it'd be pretty, but it wouldn't be very useful. So as we begin to add the base, though, down here into the acid, if we only added a few little drops of base into the acid, it would still be pretty acidic, probably. And the indicator would not show up until this began to become more basic than acidic. You see what I'm saying? So the more base you add, the more neutralization is happening down here. And if this is a highly concentrated acid, then it's going to take a lot of this base to make that neutralization happen. And what we're looking for is a gradual color change in this titration flask. And that's because as you add base, we're making salt water, no indication of anything happening. But then at a certain point, there's not going to be really any more acid left in here. It will have all been neutralized. And the moment that you see this solution that you're making in here start turning pink, that's when you know that you've just bridged the span between something being acidic and basic. You've actually added enough base down here to actually push it from the acidic side of the scale into the basic side of the scale. And we don't want to use too much of that. We just want to barely start seeing color change, and that's how we know that we have neutralized all of the acid down here. Okay, and hopefully a little video snippet that I'll insert here will show that process and make it totally clear to you. So, like everything we do in chemistry, there is some math involved, but it's not very challenging. We have an equation that we use for titration, and here it is. MAVA equals MBVB, and those terms just stand for the molarity of an acid, the volume of an acid, molarity of base, and volume of base. Okay, and so of course, in an equation like that, you have to have 3 of the variables to solve for the 4th. And so here are the derived equations for each of those variables. So if we're going to solve for molarity of acid, it's molarity of base times volume of base over the volume of acid, and so on. So I'll give you a second to get these either in your notes or memorized or whatever. But you can also just derive these on your own. It's no big deal. Okay, so let's do a problem, and hopefully this math equation will make sense. Okay, so here is the type of problem that you'll need to know how to do. If 35 milliliters of 0.5 molar sodium hydroxide titrant is used to neutralize 16 milliliters of some unknown molarity of hydrochloric acid, what is the molarity of that acid? So if we go back to our setup here, basically what we would have said was, we have some unknown molarity of acid down here, and we're starting with a volume of acid that is only 16 milliliters, okay? And then we're gonna use our 0.5 molar titrant base in here, and it looks like we've emptied 35 milliliters of base into this acid to cause that color change to occur, meaning that we've neutralized it. So let's determine, based on this stuff, what the molarity of that acid is. And so we'll just fill in what we know here. The molarity of the acid is what we don't know. We do know the molarity of, or the volume of that acid, though. That is stated in the problem. So the volume of the acid is 16 milliliters. And we know the molarity of the base from the problem. That's the 0.5 molar base. And we know the volume of the base that got used, right? The 35 milliliters. Okay, so now we can just set this up. We're going to isolate Ma by dividing both sides by 16. All right, so that puts the 0.50 molar times the 35 milliliters, all divided by the 16 milliliters here, okay? And let's go ahead and solve that up. Oh, there's my machine here. Oh, there it is. So, oops, times, oh geez, divided by 16. Okay, so here, molarity of the acid solves out to be 0.109 molar, okay? So we've determined, based on doing the titration here and the math associated with it, that the molarity of the acid is 0.109, okay? So, yeah, that's how you do those things. And I hope this helps.